Space is trying to kill us. That sounds dramatic, but it is true. Right now, there are thousands of massive rocks flying through our solar system. Most of them will never come close to Earth, but some of them will. And a handful of them have a real chance of hitting our planet in the coming decades and centuries. About 66 million years ago, an asteroid around 6 miles wide slammed into what is now Mexico. That impact wiped out the dinosaurs and about 75% of all life on Earth. The explosion was so powerful it sent debris into space, triggered massive tsunamis, sparked wildfires across continents, and blocked out the sun for years. The dinosaurs never saw it coming. They had no warning. They had no way to stop it. We're different. We have telescopes. We have early warning systems. We have scientists whose entire job is to watch the sky and track every rock that comes anywhere near us. NASA runs something called the Center for Near-Earth Object Studies. They use a system called Sentry that constantly scans for anything that might hit us. They have found over 37,000 near-Earth objects so far. About 2,500 of those are labeled potentially hazardous. But here is the scary part. We have not found them all. Scientists estimate that only about 40% of the really dangerous asteroids have been discovered. That means there could be thousands more out there that we do not even know about yet. Some of them might be hiding in the sun's glare, where our telescopes cannot see them. Today, we are going to look at the 7 asteroids that pose the biggest threat to Earth. These are the space rocks that NASA and other space agencies around the world are watching most closely. Some of them could hit within our lifetimes. Others will not arrive for centuries. But all of them deserve our attention because any one of them could change everything. Let me be clear about something before we start. None of these asteroids are certain to hit Earth. The odds for most of them are very small. But in the world of planetary defense, even a small chance matters when the consequences are this big. A 1 in 2,000 chance might sound like nothing until you realize that hitting those odds means millions of people could die. So let us talk about what is out there and what we are doing about it. Before we dive into the list, I want to explain how astronomers measure asteroid danger. There are 2 main scales. The Torino scale is simpler and designed for public communication. It goes from 0 to 10. Level 0 means no hazard at all. Levels 1 and 2 are green and represent normal situations that merit careful monitoring. Levels 3 and 4 are orange and mean, a close encounter with more than a 1% chance of collision capable of causing localized to regional destruction. Levels 5 through 7 are red and represent threatening situations with credible chances of regional to global damage. Levels 8 through 10 are reserved for certain collisions of increasing magnitude. The Palermo Technical Impact Hazard Scale is more precise and used by scientists. It compares the risk from a specific asteroid to the background risk from all other asteroids over the same time period. A Palermo rating above 0 means the asteroid poses greater risk than the average background level. A rating below 0 means it poses less risk. Most asteroids on risk lists have Palermo ratings well below 0, meaning the risk is real but still less than the general background hazard. Understanding these scales helps put everything in context. When you hear that an asteroid has a 1 in 10,000 chance of hitting Earth, that sounds alarming. But on the Palermo scale, that might register as -2 or -3. Meaning the risk is actually very small compared to the overall background. Context matters. Now let us get into the 7 asteroids you need to know about. Number 7. Asteroid 2024 IR4. We are starting with the asteroid that made headlines in early 2025 and scared a lot of people for good reason. This is 2024, year 4, and for a brief moment it was the most dangerous asteroid ever discovered. Here is what happened. On December 27th, 2024, a telescope in Chile called Atlas spotted a new asteroid. That telescope is part of NASA's asteroid hunting program, and it scans the sky every night looking for anything new. The discovery seemed routine at first. Astronomers plugged the data into their computers and started calculating where this rock would go over the next few decades. Then the numbers came back and everyone got nervous. By December 31st, just 4 days after discovery, 2024 Year 4 jumped to the top of both NASA's Sentry risk lists and the European Space Agency's risk lists. The initial calculations showed it had a chance of hitting Earth on December 22nd, 2032. That is not centuries away. That is just a few years from now. The asteroid itself is between 130 and 300 feet long. That might not sound huge compared to the dinosaur killer, but it is absolutely big enough to destroy a city. Think about the Tunguska event in 1908. An asteroid roughly this size exploded over Siberia and flattened 830 square miles of forest. It knocked down 80 million trees. The blast was heard hundreds of miles away. If that had happened over a major city instead of empty Siberian wilderness, millions of people would have died. As astronomers gathered more observations in January and February 2025, the impact probability kept climbing. By January 27th, 2025, it reached a level 3 on something called the Torino scale. That scale goes from 0 to 10 and measures both the probability and potential damage of an asteroid impact. No asteroid had ever reached level 3 before. The scale defines level 3 as a close encounter with more than a 1% chance of collision capable of localized destruction. On February 18th, 2025, the odds peaked at 3.1%. That is a 1 in 32 chance of this thing hitting Earth in 2032. For perspective, those are much higher odds than winning most lottery jackpots. If you had a 3% chance of getting hit by a car every time you crossed the street, you would never leave your house. This triggered an international response. The Space Mission Planning Advisory Group convened in Vienna to discuss options. Scientists talked about whether they would need to launch a mission to deflect it. Possible impact locations included patches of empty ocean, but also densely populated cities like Mumbai, Lagos, and Bogota. If it hit one of those places, the death toll could have been catastrophic. Fortunately, the story has a happy ending. As more observations came in through February and March 2025, astronomers were able to refine the asteroid's orbit. The more they learned about its exact path, the more certain they became that it would miss Earth. By early March, the impact probability had dropped to essentially 0. But here is the twist. While the Earth's impact threat went away, a new possibility emerged. Astronomers calculated a 4.3% chance that 2024 Year 4 might hit the Moon in December 2032. That is right. This asteroid might slam into our Moon instead. If that happens, scientists would actually be excited. A lunar impact would create a flash visible from Earth, possibly even to the naked eye. It would give researchers an incredible opportunity to study the physics of asteroid impacts and prove just how accurate their orbital predictions have become. It would be like a cosmic science experiment happening right on our doorstep. The 2024 Year 4 incident taught us something important. Our detection systems work. The early warning network spotted this asteroid within days of it becoming visible. Scientists around the world mobilized quickly to gather data. The International Asteroid Warning Network functioned exactly as designed. When a real threat appears, we will know about it. But it also reminded us that the universe can throw surprises at us with very little warning. 7 years is not a lot of time to plan a mission to deflect an asteroid. If 2024 Year 4 had turned out to be a real threat, we would have been in a very tough spot. The 2024 Year 4 case also demonstrated the importance of international cooperation. Within days of the discovery, observatories in Chile, New Mexico, Spain, and Australia were all training their telescopes on this tiny point of light. The Catalina Sky Survey contributed observations. The Gran Telescopio Canarias in the Canary Islands took a close look. Even the very large telescope in Chile dedicated precious observation time to tracking this potential threat. Perhaps most remarkably, scientists secured directors' discretionary time on the James Byrd Space Telescope to observe 2024 YO4. This is extraordinarily rare. The JWST is the most powerful and expensive telescope ever built, and its observation schedule is planned months or years in advance. Getting emergency time on it shows just how seriously the astronomical community took this threat. The JWST observations helped refine our understanding of the asteroid's size and orbit, contributing to the eventual conclusion that it would miss Earth. One thing that struck me about the 2024 Year 4 situation was how fast information spread. Within hours of the Torino scale reaching level 3, the news was everywhere. Social media was full of people asking whether they should be worried. Some news outlets ran sensationalized headlines. Others tried to provide balanced coverage. The scientific community generally did a good job communicating both the genuine concern and the high likelihood that additional observations would reduce the risk. This is the new reality of asteroid detection. We find new, potentially hazardous objects regularly when we first spot them. The uncertainty in their orbits is often large enough that Earth falls within the range of possibilities. As we gather more data, the uncertainty shrinks, and Earth usually falls outside that range. The key is maintaining perspective during the anxious period between discovery and resolution. Number 6. Asteroid 2023 TL4. Next up is an asteroid that shows how quickly a new discovery can become concerning. 2023 TL4 was discovered in October 2023 and within just 11 days of observation. Astronomers realized it was one of the most potentially hazardous asteroids we had ever found. This rock is about 1,082 feet wide, roughly the length of 3 football fields. That makes it a true city killer. If something this size hit a populated area, it would not just damage buildings, it would vaporize them. The explosion would be followed by a shock wave that would flatten everything for miles around. Fires would spread across the impact zone. Debris would rain down over an even larger area. Based on observations collected between October 8th and October 19th, 2023, astronomers calculated that 2023 TEL4 has a 0.00055% chance of striking Earth. That is about 1 in 181,000 odds. The potential impact date is October 10th, 2119. Now, 2119 is nearly a century away. None of us will be alive to see it, but that does not mean we should ignore it. In fact, having this much warning time is actually a good thing. It gives future generations plenty of time to prepare if the threat becomes more certain. If 2023 TL4 were to hit Earth, it would release energy equivalent to 7.5 billion tons of TNT. To put that in perspective, the atomic bomb dropped on Hiroshima released about 15,000 tons of TNT equivalent. This asteroid would be 500,000 times more powerful than that. It would be 150 times more powerful than the Tsar bomber, the largest nuclear weapon ever detonated. The explosion would not end the world. Earth has survived worse, but it would cause massive destruction over a regional area. Depending on where it hit, millions of people could die instantly. If it hit the ocean, it would generate tsunamis that could devastate coastal cities thousands of miles away. The secondary effects, including dust in the atmosphere and potential crop failures, could affect people on the other side of the planet. The discovery of 2023 Telfer demonstrates how modern sky surveys are getting better at finding these objects early. Telescopes like Pan-STARRS and Atlas are spotting mid-sized asteroids earlier than ever before. The more lead time we have, the more options we have for doing something about them. Right now, 2023 Telfer is being closely monitored. More observations will help refine our understanding of its orbit, like many newly discovered asteroids. Small changes in its predicted path caused by gravitational tugs from other planets or the subtle push of solar radiation could significantly alter where it ends up a century from now. There is a good chance that future observations will either raise the alarm or more likely remove it from risk lists entirely. Number 5. Asteroid 2007 FT3. The Lost Asteroid. This one is different from the others because we do not actually know where it is. 2007 FT3 is what scientists call a lost asteroid. It was discovered in 2007, observed for just 1.2 days, and then disappeared into the darkness of space. No one has seen it since. The asteroid is estimated to be about 1,000 feet across. That is big enough to level a major metropolitan area. When scientists first spotted it in 2007, they were able to track it at 14 different points over those brief 2 days. That was enough to calculate a rough orbit, but not enough to pin down exactly where it would be years later. Based on those limited observations, NASA's Center for Near-Earth Object Studies has identified 89 potential times when 2007 FT3 could impact Earth. The dates with the highest probabilities are October 5th, 2024 and March 3rd, 2030. Wait, October 2024 has already passed. So what happened? Nothing. The asteroid did not hit us. Their potential impact window came and went without incident, which actually tells us something useful. It means the orbit was slightly different than the worst-case calculations suggested. The fact that 2007 FT3 did not show up in October 2024 helps narrow down where it actually might be. The March 2030 date still has a calculated probability of about 1 in 10 million. That sounds incredibly small, and it is. For comparison, your odds of being struck by lightning in any given year are about 1 in 1.2 million. You are 10 times more likely to get hit by lightning than to be hit by this asteroid. NASA has been clear that there is nothing to worry about. In response to media reports about 2007 FT3, the agency stated that there are no known asteroid impact threats to Earth at any time in the next century. The lost asteroid remains on tracking lists purely because of the uncertainty. We have not seen it in nearly 2 decades, so we cannot rule out certain possibilities. But that does not mean those possibilities are likely. If 2007 FT3 were to hit Earth, it would release energy equivalent to about 2.6 billion tons of TNT. That is massive, but still only about a third of what 2023 TL4 would release. It would cause severe regional destruction, but would not threaten human civilization as a whole. The case of 2007 FT3 highlights a challenge in asteroid tracking. Back in the late 20th and early 21st centuries, sky surveys were less comprehensive. Objects could be spotted briefly and then lost before enough observations were made to determine a precise orbit. Today, that is much less likely to happen. Modern surveys scan the entire sky multiple times per month. An asteroid the size of 2007 FT3 would be very hard to miss for long. At some point, 2007 FT3 will probably be rediscovered. When that happens, astronomers will quickly be able to calculate its precise orbit and either confirm it poses a threat or more likely remove it from risk lists entirely. Until then, it remains a ghost in our catalogues. A reminder that there are things out there we have seen once and then lost track of. Number 4. Asteroid 1979 XB, the longest lost asteroid. If you think losing track of an asteroid for 17 years is bad, wait until you hear about this one. 1979 XB has not been seen for over 45 years. It was discovered on December 11, 1979, observed for just 3.9 days, and has never been spotted again. This is one of the largest lost asteroids on the risk list. Estimates put it at about 2,000 feet in diameter, nearly as tall as the Burj Khalifa. An object this size hitting Earth would be catastrophic on a scale we have never witnessed in recorded history. The crater would be several miles wide. The initial explosion would level everything within a radius that could encompass an entire metropolitan area. Based on the brief observations from 1979, scientists have calculated a 1 in 1.8 million chance of an impact on December 14, 2113. The asteroid has a highly elliptical orbit that takes it far from Earth most of the time, which is part of why it has been so hard to find again. It spends most of its journey in the outer reaches of the inner solar system, where it is too faint to detect. If 1979 XB were to hit Earth, the energy released would be equivalent to about 30 billion tons of TNT. That would make it one of the most destructive events in human history. A land impact would devastate an entire region. An ocean impact would generate tsunamis capable of destroying coastal cities across entire ocean basins. The good news is that the probability is extremely low. At 1 in 1.8 million odds, it is not something anyone should lose sleep over. The asteroid remains on risk lists purely because of the uncertainty in its orbit. We simply do not know enough about where it is to completely rule out a future collision. Modern sky surveys like the upcoming Vera Rubin Observatory are expected to find objects like 1979 XB. Once the observatory comes online, it will scan the entire visible sky every few nights. A 2,000-foot asteroid would not stay hidden for long under that kind of scrutiny. Within a few years, we should either rediscover 1979 XB and learn its true orbit, or have enough data to be confident it poses no threat. The existence of lost asteroids like 1979 XB is one reason why planetary defense experts push for continuous sky surveys. Every asteroid we find and track is one less unknown variable. The goal is to eventually have a complete census of everything large enough to threaten us. Number 3. Asteroid 29075 1950 DA. Now we are getting into the really dangerous ones. 1950 Da was the first asteroid to be officially recognized as having a significant chance of impacting Earth. For years, it held the highest position on the Palermo Technical Impact Hazard Scale, which is the tool scientists use to assess long-term asteroid risks. This asteroid has an unusual history. It was first discovered on February 23, 1950, observed for 17 days, and then lost for half a century. In December 2000, astronomers found it again, without initially realizing it was the same object. When they connected the old and new observations, they suddenly had 50 years of data to work with. In March 2001, 1950, Da passed relatively close to Earth at about 5 million miles. Scientists used this opportunity to study it with powerful radar at the Goldstone and Arecibo observatories. The radar data revealed that 1950 DA is about 0.8 miles across. That is big, really big. An asteroid this size hitting Earth would be a global catastrophe. When scientists plugged all this data into their orbital models, they discovered something alarming. On March 16th, 2880, there is a chance that 1950 DA could collide with Earth. Back in 2002, they calculated the probability as high as 1 in 300. That was the highest impact probability ever assigned to an asteroid at the time. Since then, continued observations and more sophisticated models have revised the risk downward. As of the most recent calculations, the impact probability is about 1 in 2,600, or roughly 0.038%. That is still significant for an object this large. If 1950 Da were to hit Earth, the consequences would be devastating on a scale never witnessed in human history. The impact would release energy equivalent to tens of billions of tons of TNT. It would create a crater many miles wide. The ejected material would spread across vast distances. Depending on where it hit, entire countries could be destroyed instantly. Even if it hit the ocean, the resulting tsunamis would likely kill millions. The impact would also have global effects. Dust and debris thrown into the atmosphere would block sunlight, potentially causing temperatures to drop worldwide. Crops would fail. The global economy would collapse. Human civilization would survive, but it would be changed forever. One of the challenges with predicting 1950 DA's orbit so far into the future is something called the Joukowsky effect. As the asteroid rotates in sunlight, different parts of its surface heat up and cool down. When the warm side radiates heat into space, it creates a tiny thrust that slowly changes the asteroid's orbit over time. For an object 850 years from potential impact, this effect becomes significant. Scientists have also discovered that 1950 Da rotates very fast. It completes one spin every 2.1 hours. For an asteroid of its size, that is near the limit of what should be possible. The centrifugal force should tear it apart. This suggests that 1950 DA might be held together by internal forces beyond just gravity. Possibly weak chemical bonds called van der Waals forces. Understanding this is important because it affects how we might deflect it if needed. The good news is that 850 years is an enormous amount of time. If 1950 DA does turn out to be a genuine threat, future generations will have countless options for dealing with it. Even a slight nudge applied decades or centuries in advance could change its path enough to miss Earth by millions of miles. Scientists have even suggested some low-tech solutions, because the asteroid's future path is so sensitive to small forces. Something as simple as coating its surface with reflective paint or chalk dust could alter how it absorbs and emits heat enough to change its orbit over centuries. We do not need nuclear weapons to deal with this one. We just need time, which we have plenty of. Number 2. Asteroid 99,942, Apophis, the god of chaos. Apophis is probably the most famous asteroid on this list, named after the ancient Egyptian god of chaos and destruction. This space rock terrified the world when it was first discovered in 2004. For a brief period, astronomers thought there was a very real chance it would hit Earth in 2029. The asteroid is about 1,100 feet across, roughly the height of the Empire State Building. It is larger than 5 football fields laid end to end when the first impact probabilities were calculated. Some estimates put the chance of a 2029 collision at nearly 3%. That was terrifying enough to make headlines around the world. Fortunately, additional observations ruled out a 2029 impact. But the fear did not go away. Scientists knew that Apophis would still pass extremely close to Earth that year. How close? About 19,000 miles from our surface. That is closer than the satellites we use for GPS and television. That is 10 times closer than the moon. For a few hours on April 13th, 2029, which happens to be a Friday the 13th, Apophis will be so close that people in Europe, Africa, and Asia will be able to see it with their naked eyes as a point of light moving across the sky. The concern shifted to what might happen after 2029, when Apophis passes so close to Earth. Our planet's gravity will significantly alter its orbit. Scientists worried that this gravitational interaction might push Apophis through something called a keyhole, a small region of space that would set it up for a collision on a future pass. For years, the most concerning date was 2068. Models showed that if Apophis passed through a very specific keyhole in 2029, it could come back and hit us 39 years later. The keyhole was tiny, just about 700 feet across, but the consequences of hitting it would be catastrophic. In March 2021, everything changed. Scientists used radar observations from NASA's Goldstone facility and the Green Bank Observatory to track Apophis with unprecedented precision as it made a distant approach to Earth. The new data allowed them to calculate its orbit with extreme accuracy, down to just a few kilometers of uncertainty. The result was good news. Apophis will miss the keyhole in 2029. It will not hit Earth in 2068. In fact, scientists have now ruled out any impact for at least the next 100 years. On March 26, 2021, the European Space Agency officially removed Apophis from its risk list. After 17 years of watching this rock, we finally know it is not going to hurt us. But Apophis is not leaving our story just yet. The 2029 flyby will be one of the most incredible astronomical events of our lifetimes. An asteroid of this size passing this close to Earth has never happened in recorded human history. Scientists estimate that something like this occurs only once every few thousand years. Both NASA and the European Space Agency are sending missions to study Apophis during the flyby. NASA is redirecting its OSIRIS-REx spacecraft, now renamed OSIRIS-REx, to rendezvous with the asteroid just before it reaches Earth. The spacecraft will observe how Earth's gravity affects Apophis, possibly triggering quakes and landslides on its surface. It will study what lies beneath the asteroid's outer layer. The European Space Agency is launching a mission called Ramses that will accompany Apophis through its close pass. This is the silver lining of the Apophis scare. For nearly 2 decades, This asteroid was the poster child for hazardous space rocks. It pushed scientists to develop better tracking methods, better orbital models, and better prediction tools. Now that we know it is safe, it is giving us an unprecedented opportunity to study a potentially hazardous asteroid up close and learn how to protect ourselves from future threats. If Apophis had hit Earth, the destruction would have been immense. A 2020 NPR article quoted researchers saying a direct hit could kill 10 million people. The impact would release energy equivalent to over 1 billion tons of TNT, enough to destroy a large country or create tsunamis that would devastate coastlines around an entire ocean. Apophis taught us that even asteroids we think are dangerous can turn out to be harmless with enough observation. It also taught us that the line between safe and catastrophic can be very thin. A difference of a few hundred feet in where Apophis passes in 2029 would have meant the difference between a close call and a collision 39 years later. The universe operates on scales that are hard to comprehend, but the details matter. Number 1. Asteroid 101,955 Bennu, the most dangerous asteroid. We have saved the scariest one for last. Bennu is currently considered the most dangerous known asteroid in our solar system. It has the highest cumulative probability of impacting Earth of any large object we have found. Bennu was discovered in 1999 and was immediately flagged as a potentially hazardous asteroid because of its size and orbital path. It is about 1,600 feet in diameter, roughly the height of the Empire State Building. It passes close to Earth every 6 years, sometimes coming within 186,000 miles of our planet. Unlike some asteroids on this list that we have only glimpsed briefly, Bennu is one of the best studied objects in the solar system. NASA's OSIRIS-REx spacecraft spent over 2 years orbiting it, mapping its surface in exquisite detail, and even collected a sample from its surface that was returned to Earth in September 2023. Scientists now know more about Bennu than almost any other asteroid. All that data has allowed researchers to calculate Bennu's orbit with unprecedented precision, and the numbers are concerning. Bennu has a cumulative 1 in 1,750 chance of hitting Earth between 2,178 and 2,290. The single most dangerous date is September 24th, 2182, when the probability peaks at about 1 in 2,700. Those odds might sound small, but they are actually significant by astronomical standards. It means there is about a 99.94% chance that Bennu will not hit us. But it also means there is a 0.06% chance that it will. For an object capable of causing regional devastation, that is not a number to ignore. The key date is September 2135. That year, Bennu will pass within about 125,000 miles of Earth. That approach itself is not dangerous, but Earth's gravity will bend Bennu's orbit. Where exactly Bennu ends up after that close approach determines everything about its future. If Bennu passes through certain gravitational keyholes in 2135, it could be set up for a collision decades later. Scientists have identified several such keyholes ranging from a few hundred feet to a few miles wide. The uncertainty in Bennu's trajectory as it approaches 2135 is currently about 6,000 miles. That sounds like a lot, but it is actually incredibly precise for predicting where something will be over a century from now. If Bennu were to hit Earth, the impact would release energy equivalent to about 1.4 billion tons of TNT. That is more than 20 times the energy of the largest nuclear weapon ever detonated. It would create a crater 4 to 6 miles wide. The explosion would flatten everything within a much larger radius. Secondary effects, including fires, shockwaves, and ejected debris, would cause destruction across hundreds of miles. Bennu is not big enough to cause a mass extinction. The dinosaur killer was about 6 miles wide. Bennu is only 0.3 miles wide. But it is absolutely big enough to end millions of lives and cause damage measured in trillions of dollars. If it hit a populated area, it would be the worst natural disaster in recorded history by a huge margin. The samples returned by OSIRIS-REx are teaching us exactly what Bennu is made of. Initial analysis has revealed that Bennu contains water-bearing minerals, organic molecules including amino acids, and material that predates the formation of our solar system. Scientifically, this is incredibly exciting. It suggests that asteroids like Bennu may have delivered the building blocks of life to early Earth, for planetary defense. This information is also crucial. Bennu is what scientists call a rubble pile asteroid. It is not a solid rock. It is a loose collection of boulders and debris, held together primarily by gravity and weak cohesive forces. This affects how we might deflect it. A kinetic impactor like the DART mission might work differently on a rubble pile than on a solid object. We have over 100 years before Bennu's critical approach in 2135. That is time enough to develop multiple deflection options, test them on other asteroids, and refine our techniques. If Bennu does turn out to be on a collision course after 2135, we will have decades of additional warning before the actual impact. There is every reason to believe we can handle this threat if it materializes. NASA's Planetary Defense Coordination Office continues to monitor Bennu's orbit. Future observations during its close approaches will further refine our understanding of where it will be in 2135 and beyond. The better we know its path, the more certain we can be about whether it poses a genuine threat or whether it will miss us entirely. After going through these 7 asteroids, you might be feeling a little nervous. That is understandable. Massive rocks flying through space that could destroy cities or even end civilizations is not exactly comforting. But here's the thing. We are not helpless. For the first time in the 4.5 billion year history of our planet, there is a species living on it that can actually do something about asteroid threats. The dinosaurs never had a chance. We do. The first line of defense is detection. We cannot stop what we cannot see. NASA and other space agencies around the world have been conducting systematic surveys of near-Earth objects for decades. As of now, we have found over 37,000 near-Earth asteroids. About 2,500 of those are classified as potentially hazardous based on their size and orbital characteristics. Scientists estimate we have found about 95% of the really big ones. The asteroid is over half a mile in diameter that could cause global catastrophe. For smaller objects, like the city killers on our list, the estimate is closer to 40%. That means there could still be thousands of dangerous asteroids we have not found yet. New telescopes are coming online to change that. The Vera Rubin Observatory in Chile will begin operations soon. It will scan the entire visible sky every few nights, finding thousands of new asteroids every year. NASA is also developing a space-based infrared telescope called NEO Surveyor that will be able to find asteroids hiding in the sun's glare that ground-based telescopes cannot see. Detection is only the first step. If we find an asteroid heading for Earth, we need to be able to do something about it. That is where deflection comes in. In September 2022, NASA conducted the most important planetary defense test in history. The Double Asteroid Redirection Test, or DART mission, deliberately crashed a spacecraft into an asteroid named Dimorphos to see if we could change its orbit. Dimorphos was about 530 feet across, roughly the size of a dangerous city-killer asteroid. The results exceeded expectations. The DART spacecraft was only about 1,200 pounds, but it was traveling at 14,000 miles per hour when it hit Dimorphos. The impact shortened the asteroid's orbital period around its companion asteroid by 32 minutes. NASA had set a success threshold of just 73 seconds. DART achieved 25 times that. This was the first time humans had ever deliberately changed the motion of a celestial object. It proved that kinetic impactor technology works. If we find a dangerous asteroid heading our way, we can hit it with a spacecraft and push it off course. Given enough lead time, even a small change in velocity applied years or decades before impact can cause an asteroid to miss Earth by thousands or millions of miles. The DART success also reveals something important. The impact ejected a huge plume of debris from Dimorphos. That debris acted like rocket exhaust, pushing the asteroid even more than the spacecraft impact alone. For rubble-pile asteroids like Bennu, this boost effect could make deflection much more effective than originally calculated. But kinetic impactors are not the only option. Scientists have proposed several other methods depending on the size of the asteroid, how much warning time we have, and what the asteroid is made of. Gravity tractors involve parking a heavy spacecraft near an asteroid and using gravitational attraction to slowly tug it off course over many years. This method is gentle and precise, but requires a lot of lead time. Ion beam deflection uses spacecraft to fire particles at an asteroid, gradually pushing it like a gentle wind. This can be sustained over long periods and does not require actually touching the asteroid. For really large asteroids or situations where we have very little warning, nuclear devices might be necessary. The idea is not to blow up the asteroid like in the movies. That would actually make things worse by creating multiple impactors instead of one. Instead, a nuclear explosion near the asteroid's surface would vaporize material that jets off into space, pushing the asteroid in the opposite direction. The important thing is that we have options, and we are actively working to develop and test more. The European Space Agency is launching the Hera mission in 2024 to return to Dimorphos and study exactly what DART did to it. That information will help us plan future deflection missions. Asteroid impacts are different from other natural disasters. Earthquakes, hurricanes, volcanic eruptions. They are all terrible, but they are also local. Even the worst ones affect one region at a time, and there is nothing we can do to prevent them. Asteroid impacts can be global. A large enough rock hitting Earth could end human civilization. But unlike other natural disasters, we can actually prevent them. With enough warning and the right technology, we can stop an asteroid before it reaches us. That makes planetary defense unique. It is the only natural existential risk we have the technology to completely eliminate. We just need to invest in finding the threats and developing the tools to deal with them. Right now, none of the asteroids on our list pose an imminent threat. The highest probability impact, 2024, Year 4, at 3.1%, turned out to be a false alarm. Bennu has only about a 0.06% chance of hitting us, over the next few centuries. Those are small numbers, but small numbers add up over time. If we do nothing, eventually our luck runs out. The universe has been throwing rocks at Earth for 4.5 billion years, and it is not going to stop. The question is whether we will be ready when the next big one comes. The Tunguska event in 1908 flattened 830 square miles of forest. If that had happened over London or New York, millions would have died. The Chelyabinsk meteor in 2013 injured over 1,500 people when it exploded in the atmosphere over Russia. That rock was only about 60 feet across. The asteroids on our list are 10 to 20 times larger. History shows that impacts happen. The only question is when the next one will be, and whether we will see it coming. So there you have it. The 7 most dangerous asteroids currently known to be heading toward Earth. From 2024, year 4 that briefly terrified the world before turning out to be harmless, to Bennu that will keep scientists watching the skies for the next century and a half. Here is what I want you to take away from this. Yes, there are massive rocks out there that could hurt us, but we are watching. We have telescopes scanning the sky every night. We have early warning systems that work. We have already tested technology that can deflect asteroids. And we have brilliant people all over the world working on this problem. The dinosaurs never had a chance because they never saw it coming. We are different. We have the ability to find threats decades or centuries before they arise. And we have the technology to do something about them. The universe is a dangerous place. But for the first time in Earth's history, something lives on this planet that can look up, see the danger, and push back. That is pretty incredible when you think about it. Thanks for reading all the way through this one. These deep dives take a lot of research, and I appreciate you sticking with it. If you found this interesting, share it with someone who might enjoy learning about what is flying around out there in the dark. And remember what I asked at the beginning. Drop a comment with where you are watching from and what time it is. I love seeing how this community spans the whole globe. We are all on this pale blue dot together, sharing the same sky and the same risks from what is flying through it. Stay curious, stay informed, and keep looking up.